This is chapter 6 of HL, complex numbers and polynomials. 6a, we're going to talk first about what happens when you have a result in the quadratic formula when the inside of the radical is negative and you don't have a real solution. Okay, so when you solve the standard form quadratic equation set to 0, and I'm going to write that here. Standard form quadratic equation, if you remember, is ax squared plus bx plus c set to 0. So when you solve this equation, find the x values that make this true, you use the quadratic equation. And when you, the discriminant, which is b squared minus 4ac, is the part that goes inside the radical there, right? Okay. And let's move on. When the discriminant is less than 0, the solutions of the quadratic equation are not real since negative numbers do not have a square root. The imaginary number I, which is equal to the square root of -1, is defined by Bombelli. So Bombelli realized that if you have the square root of a negative number, what you could do, like let's say you have the square root of -25. The square root of -25 is equal to the square root of -1 times the square root of 25, positive 25. So that's equal to the square root of -1 times 5. So you can kind of solve this problem of having negative numbers just by inventing a square root of -1 and just like using that as a factor with regular positive numbers that do have square roots. The number a plus bi, that's called a complex number because complex numbers have a real part, which is the a part, and it's got the imaginary part, which is b, which is a real number, times I, which is square root of -1. By multiplying a real number b times the square root of -1, I, you can get a imaginary number that is not just square root of -1, it's square root of -1 times a bigger number, right? Okay. All right, let's move on. So there are these examples in the book. And number 1, for the problem set, we're going to write in terms of I, square root of -9. Now remember, square root of -9 is square root of -1 times the square root of positive 9. So that's equal to I times 3. Okay, and you can write that as I times 3 or 3 times I. Let's do that with square root of -4. Square root of -4 is equal to the square root of -1 times the square root of 1/4. And remember that the square root of 1/4 is equal to the square root of 1 divided by the square root of 4, which is equal to 1/2, right? So we have 1/2 I. What about square root of -8? Square root of -8 is equal to the square root of -1 times the square root of 8. Square root of 8 is 2 square root of 2. So this is equal to 2 square root of 2 I. And you can put the I before or after, either way. Solve for x. Okay. So we have x squared minus 25 equals 0. There's a couple ways you could do this. One of the ways is you could say, okay, x squared equals 25. X, take the square root of both sides, and you get x equals plus or minus the square root of 25, which is equal to plus or minus 5. The other way you could do it is you could say, okay, x squared minus 25 factors into x plus 5 times x minus 5. So the way that x plus 5 times x minus 5 would become 0 would be either x equals -5 or x equals +5. So either way we can get the two solutions, -5 and 5. Now here let's do a little trickier one, x squared plus 25. Okay, x squared plus 25 does not appear to factor into real numbers like this, okay? What if we use the other method? X squared equals -25, x equals plus or minus the square root of -25, x equals plus or minus the square root of -1 times the square root of 25. So basically what this says is that x is equal to plus or minus, plus or minus 5i. Okay? The other way you could do it is you could use the quadratic formula, and C is 25, A is 1, and B is 0. With these numbers plugged into the quadratic formula, you will find out that the only part, the negative b is 0, right? So you just end up with square root of b squared minus 4ac, which is going to be square root of negative 25. Not negative 25, I'm sorry. It would be b squared minus 4ac, so minus 100, divided by 2a. Okay, and square root of negative 100 over 2 is equal to square root of I times the square root of 4 times the square root of 25. Square root of 4 cancels out with the 2 on the bottom, so you get 5i, because square root of 25 is 5. Okay, x squared minus 4x equals 0. So here we could factor out an x, right? So we could say x times x squared minus 4 equals 0. So x times x plus 2 times x minus 2 equals 0. So the possible solutions would be x equals 0, x equals negative 2, and x equals positive 2. Okay, what about this one? X cubed, we're going to factor out an x here, so we'll have x squared plus 4 equals 0. Okay, so remember that x squared plus 4, you could factor this, you could factor it into x plus 2i, x minus 2i. Let's multiply this out to make sure that it really works. So you would have the first two terms multiplied together with the x squared. The last two terms, plus 2i and negative 2i multiplied together, would give you negative 4i squared. I squared is negative 1. So negative 4i squared would be positive 4. And then the middle terms would be plus 2ix and minus 2ix. Do you see how the middle terms cancel each other out? So then you're just left with x squared plus 4. So we figured it out. Now let's try to solve for x. So like from this, these two factors multiplied together, we can see that one of the factors would be negative 2i and the other factor would be positive 2i. Okay, x would equal negative 2i or positive 2i. Let's look at this one. So x cubed minus 3x, you could factor out an x. X squared minus 3 equals 0. You could factor x squared minus 3 into the product of the sum and the difference of x and square root of 3. Okay, equals 0. So the two possibilities for x, or the three possibilities, are 0, positive square root of 3, and negative square root of 3. Let's do x squared minus 4. So x squared minus 4, this is a factoring problem. You could factor x to the fourth minus 1 into the sum and product of the two terms. So x to the fourth, x squared plus 1 and x squared minus 1. And then you could further factor x squared minus 1 into x plus 1, x minus 1. We could factor x squared plus 1 into x plus I and x minus I. Let's check that. If we multiply I times minus I, we get negative 1 times negative 1, which is positive 1. Yeah, and the middle terms cancel out. Looks good. So the solutions here would be x equals I, negative I, 1, and negative 1. Okay, number 4. Solve for x. Okay, so we got x squared minus 10x plus 29 equals 0. I think we're going to have to use quadratic formula because this does not look factorable. So x equals negative b, negative 10, plus or minus b squared, which is 100, negative 10 squared is 100, minus 4 times a, which is 1, times c, which is 29, divided by 2. So negative 10 is positive 10, so it'd be 10 over 2 plus or minus 4 times 29 is 116, right? So it'd be square root of 100 minus 116 divided by 2. So this is equal to 5 plus or minus square root of negative 16 divided by 2. And let's see. Okay, so this would be 5 plus or minus square root of negative 16 is 4i divided by 2, which is equal to 5 plus or minus 2i. Right? All right, let's look at C. X squared plus 14x plus 50 equals 0. Okay, I don't see this as being easily factorable either. Okay, you know, if the roots are going to be complex, it's not going to be easily factorable. Okay, x equals negative 14 plus or minus square root of b squared, which is 14 squared, minus 4 times a, which is 1, times 50. So 4 times 50 is 200, so I'm just going to write 200 here. And I'm going to divide by 2a, which is 2. So it would be negative 7 plus or minus square root of 14 squared minus 200. Let's see what 14 squared is on the offline calculator. 14 squared, 196. So that's 196 minus 200 divided by 2. So that would be negative 7. So the plus or minus 196 minus 200 is square root of negative 4 divided by 2. So negative 7 plus or minus square root of negative 4 is 2i. 2i divided by 2 is I. So the answer is negative 7 plus or minus I. One last one on this page. X squared minus 2 square root of 3x plus 4. So now what we're going to do is we're going to use quadratic formula with b equals that, c equals that, and a is 1. So that would be x equals negative b, so negative negative 2 square root of 3, plus or minus square root of b squared. So b squared would be 4 times 3, because 2 squared times square root of 3 squared would be 12. Okay, so b squared is 12, minus 4 times 1 times 4, which would be 16, divided by 2a, which is 2. That would be positive 2 square root of 3 divided by 2, which would be square root of 3, plus or minus 12 minus 16 is negative 4, so square root of negative 4, which would be 2i, divided by 2. So we got square root of 3 plus or minus I. Okay, and that's it for page 1.